Hello and welcome back. Is there anybody out there? Does anyone actually watch these things? I don't know. I have no idea. I think one or two of you do, so I appreciate your diligence in trying to do the right thing and learn what you're supposed to be learning, or at least as much as you can learn during these crazy times. Today we are moving on. We're going to step away from equations. We are now going to talk about next evolutionary step, which is inequalities. Inequalities. Now, you're going to recognize the symbols pretty quickly on these things. The first lesson for inequalities is pretty basic, pretty straightforward. We're talking about these symbols here. There's four of them all together. There's that one, and that one, and that one, and that one. All right, they actually have names. This one is read as less than. This one is greater than. This one here, notice it has that less than symbol, but it also has this line underneath. Most of you already know what that is. That is a combination. It is the, it is the less than or equal to. So it has the less than symbol and part of an equal sign. That's where that equal to comes into play. And this one here, again, has the greater than, or, again, there's that partial equal sign down below, equal to. Okay. So for our first lesson, pretty quick one, this will go by real fast for you guys, is just understanding which direction these arrows are supposed to point, understand how to read it when it's presented to you, and then how to graph them. So when we are given problems that look like this, and it says x is greater than 7. Okay, I'll put a little line here so we know that that's a 7. Doesn't look like or it's another symbol we're mixing up here. So this x now, instead of having one value, all those equations have equal signs. There's one value. Now there's an infinite number of answers. X can equal, well, 8 is greater than 7. 9 is greater than 7. 37 is greater than 7. 1,000 is greater than 7. All of these are viable options, and it goes up to infinity. Okay? All the way up through infinity. You have any number you want. Okay? Flip side of that is if I tell you that it is less than -3. Well, we can list a set of numbers that are less than -3. X has an infinite number of possible values. -4 is less than -3. Remember, negatives work backwards. -5 is worse, or excuse me, not worse, less than -3. -40 all the way to negative infinity. Okay, so when we read these things, we have to understand what the two symbols mean, and most of you pretty much have a grasp on that, I have no doubt already. When we throw in that extra symbol, then we have something like x is greater than or equal to 19. Okay, now x, again, infinite number of answers. In numbers that are greater than 19, well, that's 20 and 21 and 22 and so on. But it also can be equal. So now 19 is part of our set. Excuse me. I could not put 7 up here because 7 is not greater than 7. So notice 7 is not part of this set. -3 is not less than -3. So -3 is not part of that set. But now that I have this equal sign down here, now that we have the addition of x is less than or equal to 0. Well, it's everything less than, but it's also can be equal to 0. So the set that we have would include 0. It would include -1 because that's less than, and -2 and -3 and so on to -infinity. So when you're reading through these things and they're asking for sets or examples, this is what we're talking about. We're talking about the ability to understand that when to purchase something. Let's do a translation. I'm going to share my page so I have more room to write a little bit more spaced out here. All right, so word problems. Just translating. So Tommy needs $65 to buy a game. Okay, so in this case, let's say that money is our X. Okay, how much money does Tommy need to go to the store and buy the game? Well, if I was using an equal sign, if I want to know the exact amount, obviously it would be $65. However, you don't have to walk into the store with exactly $65, or ignore tax for now. Tommy can walk in with the equal amount of $65, but he can have any value more than that also. He can walk in with $66. He can walk in with $100. He can walk in with $1,000. As long as he has equal to or more than the value needed, he's all right. We're great. We can do that. Okay. Another example. Too young to drive. You guys are all getting close to that. Now, we're going to forget about permits. Let's just go with the driver's license. You need to be 16, right? If you're too young, well, this time we'll have X equal our age. So your age, if you were less than 16, you can't drive, right? If you're 12, you can't drive. If you're 13, you can't drive. If you're 15 and a half, you can't drive. If you're 15 and 11 months, you can't drive. You got to be 16. That's why there's no equal sign here, because once you hit 16, you're allowed to drive. But if we're talking about if you're too young to drive, the ages that are too young to drive, it's everything less than 16. Okay? So we think about what's being included in our story to know which symbol is being used. And you can use a little bit of note-taking to help guide you. If Tommy needs $65, you can make a little list to yourself, possible values, and we know that he could walk in with 65 and buy his game. We can walk in with 66 and buy his game. We can walk in with 70 or 300 and buy his game. It's all of the numbers that are equal to or greater than the 65. Same thing here. If you want to know possible ages, create a list to help you figure out which way the arrow is going to point. So we can have, a 1-year-old not allowed to drive, a 2-year-old not allowed to drive, a 7-year-old a 12-year-old, a 15-year-old not allowed to drive. But notice I can't put 16 because 16 you're allowed to drive. So we don't have that equal sign. This one, because we could put 65, which is our number, in our list, we have to add the equal sign because it can be that number. Here, 16 is not part of my list. That means it doesn't get that equal sign. Okay. The other thing that we're going to learn how to do real quick here is graphing these things. It's a matter of shading in a number line. Okay, so I'm going to do this. So graphing on a number line. Okay, now here's the two big symbols you need to know. And I refer to this as an open circle. And this is a closed dot. Notice one shaded in, one is not. And there's a very specific reason that we have those two. And I'm going to show you real quick which ones go to which, and then we'll see how they actually apply to a graph or to a number line. So these two symbols, the less than or greater than symbol, we're going to use the open circle. Okay. These two symbols, the less than or equal to and the greater than or equal to, for these two, whenever you look at a graph, it's going to have the closed dot. Okay. Now, what these represent, and I'm pretty sure at some point of this year we talked about how dots, when we shade in dots on a graph, they are so close together that they become a line. All we see is the shaded in line. But remember, they represent an infinite number of points on that line. It's like you're looking at your computer that you're looking at right now to see my video here. Every one of these little spots, right there, and right there, and right there, and right there. These are all little tiny dots on your screen that make it so that it all comes together and makes a picture. You don't see the dots, not unless you zoom in so far that it becomes pixelated. That's what pixelated is. It's showing you all the dots. All right, so I'm going to turn my page one more time here. So what we're going to do is we're going to shade all possible values. So they will give you, very simply, an expression. X is greater than 9. They will give you a number line. Now, a number line, because it goes infinite, that's why the arrows are there in both directions. This is just a small section of a number line. There's nothing saying that 0 has to be in the middle. It's a snapshot of some section of the entire number line. If I'm dealing with 9, I generally will try to put 9 in the middle. Okay, whatever number I'm dealing with, I put in the middle. Now I know that after 9 comes 10, and 11, and 12. And before it comes 8, and 7, and 6. Now this says X is anything that is greater than 9. So again, I can use this little note-taking to help myself see where I should be shading things in. Possible values that are greater than 9. Well, 10 is greater than 9. 11 is greater than 9. And here's where we have our, where that open circle is going to come in. 9.5. That's bigger than 9. 9.1 is bigger than 9. 9.00001. That is still bigger than 9. But notice that nowhere in my list is there a 9. 9 is not included because there's no equal sign. So because 9 is not included, but I see here that 10 is good, and 11 is good, and 9.5 is good, and 9.1 is good, and 9.1, 1, and 0.001, and every decimal, every fraction in between these numbers is good because they're all bigger than 9. Again, this is where that shading comes in. So suddenly I can take this entire thing and say, all right, everything, all those dots come together and make one line going in that direction, but not 9. And because it's not 9, we put a circle around it, an open circle. Lets the reader know that we're talking about not 9 itself, but anything bigger than 9. You know, we don't worry about if it looks like it's not close enough right here. Don't sweat that. People just know that this means anything bigger than 9. Okay, it could be 9.000000001, which is so close we couldn't even draw it. But we still draw the circle. This tells us it's in that direction. Okay, so it's everything going to infinity to the right, everything getting larger. Okay, flip side of that, let's do this one. X is less than or equal to -3. Well, let's do our possible list again. What are numbers that are less than -3? Remembering that negatives work backwards. Well, -4 is less than -3. -5 is less than -3. -6 also is less than. But what is this? I've got an equal sign. That means in my set, I'm also allowed, in this case, to actually have the number. The number itself is a good possible answer for us. That is just as good as any of the other ones that we can see here. So when we make my number line now, and I put -3 here, well, this would be -2, -1, 0. Notice 0 again, doesn't have to be in the middle. -4, -5, -6. So when I go to shade all this in, I can see my pattern. I can see that -4 is shaded in. -5 is shaded in. -4 point whatever. Everything in between is shaded in. Same from 5 to 6. 6 itself is shaded in. Everything in that direction to infinity, negative infinity, is shaded in. But in this case, not only is all of these separate things to give us the hint on which way to draw, but because 3 itself, -3 itself is a good answer, it also gets a dot, but this one gets the big dot, telling everybody that's its starting point. So the solid dot tells us that's where the equal sign is part of it. The open circle means that there is no equal sign as part of the problem. Okay, so this week, the work that I'm giving you, it's going to be a combination of these different things. It's going to be being able to take a value or take an expression and put it onto a graph, onto a number line. They'll have you do the reverse, where they'll give you the number line. You have to identify which direction it's going and put the value. So X is less than 4, or read whatever it says on the number line. And then the other stuff that I went over earlier, just knowing which direction it's supposed to point, if it's going to be with an equal sign or no equal sign. It's not that hard. It should be pretty easy. As always, if you have questions, please don't hesitate to ask. Contact me. I've really appreciated the high percentage of you who have been getting all of your work in. I am doing my best to keep up with all of it. I think I'm doing okay. It's Monday, so I'm going to be picking up all your emails that you sent me over the weekend, because I take the weekends off still. I know we had a problem with Aries. They mixed up all my worksheets somehow from like 3 weeks worth. I got all that straightened out. Shouldn't have any more problems with that, so hopefully that's all cleared up. All right, just a couple more weeks left, guys. We're almost there. And then who knows what next year is going to be like. We'll find out soon enough, I guess. All right, stay safe. Talk to you guys later. Bye.